Welcome to this day 25 learning in this machine learning playlist. Today we are going to be learning about learning curves, regularize uh, the errors with ridge and lasso, and elastic net regularization techniques. So let's quickly start. So we have a simple data set that is loaded here with a data point, something like this in a polynomial type of fashion. So now we are going to be understanding what exactly is learning curve. Learning curves helps us visualize training error and validation error in different cases, and quickly helps us understand if a specific training error is resembling of a high bias or of a high variance. So bias corresponds to underfitting, where we have less features or less data being trained with. So one example that you could quickly see here is learning curves with respect to underfitting. So linear regression is a model that we are using here, and if you see, there is small amount of data that is being used to plot this curve. And initially, if you see, the training error and validation error is super high, while the training error is has a huge difference between these two. As you increase data set or training set, the error difference between training and validation it decreases. This gives us an understanding that this is a classic underfitting signature, right? So so we need to increase the data points or increase the related features for having better model performance, right? So increasing more data is a key thing. Next thing is, with respect to having to see an example for overfitting. So in this one, we have polynomial features where we try to overfit this specific uh, data points with a polynomial degree of 10. As you see here, polynomial features is a model that we are using, and degree of 10. We are going to be looking at this polynomial features in once we start off with SVM, support vector machines, in the upcoming sessions. So as you could see, um, with the uh, small data set that we see here, initially training error is super low because we are overfitting the model, and validation error is a huge spike, uh, which should give us an understanding of overfitting. So this is a clear example of overfitting. So we might need to balance, or we might need to have a bias and variance trade off, where we have a good balance capturing overall of the curve without having to chase each and every data point, right? So there's always a good rule of between overfitting and underfitting. Okay, so that's one thing. All of these parameters with respect to error measuring was done with root mean squared error. So here I have one section where we are showing the difference between training and uh, training error in case of a linear regression model, which corresponded to the bias or underfitting, while polynomial degree of 10 was overfitting, right? So yeah, you could see the training errors here, even though they have some amount of gap. Okay, so regularization is a technique where we use coefficient parameters, which helps drop the error. Ridge is one technique which, as we increase the coefficient or the penalty value, um, the training error decreases, right? So for ridge, this is the coefficient value, and there is alpha value always that we can vary, and we could uh, see the variations in the root mean squared error, right? So that's one thing. Next is, yeah, here we are also plotting how alpha values uh, result in the training model with um, The alpha value is green. If you see, it's a smooth curve. So green is around 1. So 1 is somewhere around this one, right? So somewhat of a balance. More the curve, again it goes more of a root mean square error. Okay, so that was about it. Lasso, on the other hand, will effectively use a coefficient value such that the error tries to become 0. So performs feature selection automatically. So that's one advantage with Lasso, where in Ridge we used to adjust the alpha value to reduce the error. In Lasso, it tries to make the specific coefficient value 0, and by checking the right feature selection. That's one thing. So yeah, here we have different coefficient values with feature degree, and eventually the error turns out to be 0. So that's one thing. Elastic net is a combination of both, somewhat of a formula like this one. L1 corresponds to ridge and L2 lasso. So that's one thing too. So yeah, and finally I have a small table showing all the different models with root mean squared error and lasso and all these other things applied to it. So that was about it for today's session. It was about learning curves and how we could regularize a model to minimize the error value. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.